The experiment we carried out was looking at droplets in the atmosphere. We are specifically interested at emission originating from cooking, and we found that these fatty acid molecules arrange in surprisingly complex assemblies. And we try to understand what impact this self-assembly, so this particular complex arrangement, has on the lifetime of this organic acids. So how long do they stay in the atmosphere, how far can they travel in the atmosphere, and how does that impact the properties and lifetimes of clouds. So the complex 3D structures we found may allow these molecules to survive much longer in the atmosphere. And if they survive longer, they will affect the surface tension, so the surface properties of water-based droplets, in a way so that cloud formation is facilitated. So it will be easier to produce clouds. Because the molecule we looked at is a fatty acid, which itself might not have direct health implications. But if these molecules self-assemble and have a longer lifetime, a longer residence time, and thus can reach much further from where they're emitted into the atmosphere, that could also happen for other molecules, and some of them certainly will have significant health implications. I'm not saying we should cook more meat to solve global warming, because obviously other implications of meat cooking that might have a negative impact. But certainly it looks as if certain molecules can survive much longer in the atmosphere than previously thought. So it's urgently needed that more research is done in this area, because this is something that hasn't been considered. Also, there's lots of research activity in kind of atmospheric aerosols and looking at surfactant layers, so surface layers of these species, but looking inside the droplets and trying to establish the self-assembly inside a droplet of water is something that hasn't really been looked into.